will try to understand the process of dissolution. What happens? How is it that some substance dissolve, at room temperature, while others are insoluble, they don't dissolve, insoluble, and the third one is soluble at room temperature, soluble at room temperature. Now this thing should be considered very carefully, that what happens in dissolution. Some substances dissolve at room temperature, others never dissolve, and yet others dissolve on the supply of heat. So what is the guiding factor here? In order to understand the guiding factor here, we have to apply the concept of thermodynamics. Thermodynamics, which we have studied in class 11th. So which state function will give the answer? The answer will be given by the state function delta Z, that is gives free energy or gives Helmholtz state function. Now delta Z, as we have studied there, the delta Z has three values: positive, delta Z is 0, or delta Z is positive. Here we will get the answer of these three cases. If delta Z is positive, the process will be non-spontaneous. Non-spontaneous. It means that the substance will not dissolve in solvent at room temperature. We are bound to supply some heat. When delta Z is 0, it means that it will never dissolve in the solvent. Never dissolve in the solvent. And if delta Z is positive, it means that the substance will dissolve only on the supply of heat. On the supply of heat. Now the process of dissolution should be understood very carefully. Here the scale value is given, sign is given. If delta Z is positive, the process will be non-spontaneous. The salt will or any substance will dissolve at room on the supply of heat. If delta Z is 0, the substance will never dissolve. If delta Z is positive then substance will dissolve on the supply of the heat. Now let us try to understand what is which equation of delta Z functions here in this case. Then here delta Z is equal to lattice enthalpy minus hydration enthalpy. Hydration enthalpy. Now you know about lattice enthalpy. What is lattice enthalpy? When ions come close. Now I am trying to define this in this term, that when 1 mole of ion, when 1 mole of opposite ions comes together, then energy liberated is called lattice enthalpy. Is called lattice enthalpy. And the second term here is your hydration enthalpy. So what is hydration enthalpy? Hydration enthalpy. Whenever the ion goes into the solution, or a special phenomena occurs. As you know that water has V-shaped structure and it is polar molecule. Supposedly if any plus ion is going in water, then what will happen? The phenomena that will happen, it will attract the opposite sides. Then here a spatial orientation of water molecule take place and negative side is here. In the similar manner, if Cl minus here, this will arrange the water in opposite manner. And this phenomena, this happens due to attraction, and you know that attraction leads to the falling energy, and energy is liberated in the process. Energy is liberated in this process. And whatsoever energy is liberated here for 1 mole of ion, this is called hydration enthalpy. Now the case is very clear, the concept is very clear for you to take the decision. Now see here delta Z will come negative. What will be the case? When hydration enthalpy is more than what? Lattice enthalpy. Under this condition, the salt will dissolve in solvent without any supply of heat. But here see the case, when lattice enthalpy is equal to hydration enthalpy. Under this condition, what will happen? Delta Z will become 0. The salt will never dissolve. Never dissolve. Now see the case number 3, where lattice enthalpy is more than suppose this case lattice enthalpy is more than hydration enthalpy, then what we are going to get here? Delta Z will be positive. The salt will dissolve only when we supply heat to the solution or to the system. Then the salt will dissolve in the water. So this is one concept of dissolution which you should try to understand. Now here we are trying to go through another terms. There are certain terms associated with solution. One is called unsaturated solution. So what is unsaturated solution? Suppose a solution is prepared at room temperature and we can add further quantity of solute in it. Then the solution will be treated as unsaturated solution. Now see another case. Saturated solution. When solution is prepared at room temperature, but we cannot add any quantity of solute into the solution, then this is called saturated solution. Now we will try to understand the variation of solubility with temperature. Normally what happens, when temperature is increased, solubility normally increases, and the answer should be non-negative. What happens in this case? You know that delta Z is lattice enthalpy minus hydration enthalpy. When we supply heat, then what happens? The requisite amount of lattice enthalpy is supplied. Then here the heat is utilized in breaking the lattice, and due to which the solubility increases with rising temperature. But what will happen if we increase the temperature? Now see, in order to study this case, we have to plot a graph between what? Between solubility versus temperature graph. Now see, if such a kind of graph is plotted, you know that the graph here we have taken solubility in gram per liter and here temperature in Kelvin scale. Then it is observed that solubility increases with rise in temperature, but after a certain point it does not increase, it becomes parallel to temperature. Here the graph becomes parallel to the temperature. At this point it indicates that the solubility does not increase. Even with the rise of temperature. Whatsoever temperature we can rise, the solubility will not increase. Then this point here, this point is called supersaturation point. Supersaturation point. Supersaturation point, and the solution resulted prepared at this point is called supersaturated solution. Supersaturated solution. Now we will try to understand how to measure the concentration of the solution. Okay. First of all, we have to take the physical meaning of concentration of solution. What it is? Concentration of solution. What is the physical sense of this statement? Concentration of solution simply gives the idea that how much solute is present in 1 liter of solution or in 1 kg of solvent. This thing should be cared very. Now see, with utmost care we have to take this thing in 1 kg of solvent and 1 liter of solution. Concentration. In order to measure the concentration of a solution, there are several ideas in chemistry. Now we are going to discuss this one. Molarity. What is molarity? Now see, this is one criteria to measure the concentration of the solution. What is molarity? Let us see this thing. Molarity is defined as the number of moles of solute. Moles of solute present in 1 liter of solution. Molarity is represented by capital M. Wherever capital M is written, it means concentration is measured in molarity. Now see, if you want to give the formula of molarity, then here the formula will be likewise M. Molarity is number of moles of solute divided by volume of solution in liter. Now here we have to see some of the things, how to announce certain symbolic expressions. Suppose here, if the strength of solution, concentration of solution is given as m by t, what does it mean? How to dict this concentration? This concentration is dictated in the way decimolar solution. In the same way, if m by 100 is written, it means centimolar solution. Similarly, if I am using another symbol 5m, then what does it mean? It means that we are talking about bench solution. So this is one scale about to measure the concentration of solution, that is molarity. What is molarity? Number of moles of solid present in 1 liter of solution. It is represented by capital M, and here M is number of moles of solid divided by volume of solution in liter, and these are the things which are associated with molarity. Now we will switch on to another topic or another scale to measure the concentration of the solution, and that scale is what? Molality. Say here, molality. The words sound similar, molarity and molality, but there is some difference in the announcement of the two words. So molality, what is it? Molality is defined as the number of moles of solute. Number of moles of solute present in 1 kg of solvent. 1 kg of solvent. Now try to see the difference in molarity and molality In molarity, we have considered the volume of solution, and in molarity, we are considering 1 kg of solvent, not that of solution. So, formulatively, we can write this thing. This is represented by K small m. Now, if you want to give the idea in formulative way, then m will be equal to number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. Now this thing is over. Now we will try to study another scale to measure the concentration of the solution further. Now see, the third scale is normality. Normality. What is normality? Number of equivalent weights of solute present in 1 liter of solution. See, number of equivalent weights. Number of equivalent weights of solute present in 1 liter of solution. In 1 liter of solution. We can represent this thing mathematically also. This is represented by capital N. Wherever capital N is written, it means that we are talking about normality. Then N is equal to number of equivalent weights. Equivalent weights divided by volume of solution in liter. Now, equivalent weight is a big concept and we should try to understand what equivalent weight is, but here in the syllabus, we have not to study equivalent weight. That's why we will see certain ideas of equivalent weight. How to compute equivalent weight? Now see, if you want to compute the equivalent weight of acid, equivalent weight of acid is equal to molar mass of acid, molar mass of acid divided by basicity of acid, basicity of acid. In the same way, if you want to find out the equivalent weight of base, equivalent weight of base, then this can be calculated by molar mass of base, molar mass of base, now divided by acidity of base, acidity of base. In the same way, if you want to find out the equivalent weight of different type of substances, we can do it also, like oxidizing agent. So equivalent weight of oxidizing agents, oxidizing agents. The equivalent weight of oxidizing agents are calculated by molar mass of oxidizing agent, molar mass of oxidizing agent divided by number of electrons received, number of electrons received. So now last thing, we will study about the equivalent weight of reducing agent, how we can compute that thing. So equivalent weight of reducing agent, say here, equivalent weight of reducing agent is molar mass of reducing agent divided by number of electrons released. Okay guys, I hope that you have learned chemistry with me. Thank you all of you.